Welcome to part 2 of our chapter 1 review packet. So we left off at number 9, where we're trying to find both the domain and the range. So let's first start with the domain. We see the radical, so we know what's inside the radical must be greater than or equal to 0. So subtracting 49 from both sides, negative x squared is greater than or equal to negative 49. Now, when we divide by negative 1 to get rid of the negative, we must flip the inequality sign. So we get x squared is less than or equal to 49. So when we take the square root of both sides, we get the absolute value of x is less than or equal to 7. So rewriting this as a compound inequality, we know that x is less than or equal to 7, and x is greater than or equal to negative 7. And that would be the domain in interval notation. Now, to find the range, we just really need to think about that radical expression. We first know that this will never be equal to a negative quantity. So the bottom end of the range is 0. So once again, that's the domain. There's the domain. Then for the range, it goes from 0. Now, what's the biggest this could be? Well, we know that x squared must always be non-negative. So if x squared is 0, 49 minus 0 is 49. And radical 49 is equal to 7. So the range is from 0 to 7. Okay, number 10, once again, domain and range. So looking at our function, I see no radicals, and I see no denominators that could be equal to 0. So I know that the domain is all real numbers. Now for the range, I want to look at each part of the polynomial individually. I've got 5. That's a constant. It's always equal to 5. And I know that x squared can never equal a negative quantity. So the smallest this could be is when x is 0. 2 times 0 is 0. 0 plus 5 is 5. So I know the left end of the interval is 5. And there's really no limit to what 2x squared can equal, because this is going to produce a parabola. So the range is from 5 to infinity. Answer C. Okay, number 11. Use the vertical line test to determine which graph represents y as a function of x. So recall, to pass the vertical line test, we can't have any vertical lines that pass through more than one point of the graph. So looking at A, no matter where we draw a vertical line, it passes through at most one point. So we know A is the answer. Now let me explain why the others are not functions of x. If you look at graph B, at x equals 4, I could draw a vertical line that passes through 2 points. So I have one input that has 2 outputs, not a function. With graph C, it fails at x equals negative 4. It passes through more than 1 point. So C is not a function. And then for D, it's violated at two different values of x, so it's not a function. Number 12. Determine the intervals on which the function is increasing, decreasing, or constant. So for the increasing interval, we look, where is the graph going up from left to right? And we notice that it starts going up at about x equals 4. So increases from 4 to, it looks like, infinity. Then decreasing, it looks like it's decreasing at every value up until 4. So that would be from negative infinity to 4. Now notice that I use parentheses here. That's because at x equals 4, the graph is not increasing nor decreasing. So our answer is A. Okay. So now for number 13. It looks like it's increasing in this interval and in that interval. And then from these two x values, it looks like it is decreasing. So it looks like it's increasing from negative 7 to negative 5. Also, it's increasing from negative 1 to positive 1. And the graph is decreasing from negative 5 to negative 1. So the answer is C. Now, on number 14, it asks you to use a graphing utility. Now, looking at the graphs, you can actually figure out these relative minimums and maximums pretty easily. But let's go ahead and go through the process because it's unlikely I'd actually give this to you as far as a multiple choice on the actual test. Let me fix the focus or the color. So I'll go ahead and type in my equation. So this is the part of the graph I see on the standard viewing window. I don't see the changes in direction, so I'm going to need to change my window. Now, it looks like my x is okay, but I will need to change the window for y. So let's say I try from negative 30 to 30. Now, you could have picked a different value, but once you push graph, you should be able to see whether it was appropriate. Well, it looks like I just missed the little peak here, which would be a relative maximum. So I'm going to go ahead and change my window, and I'm going to make y max 40. And hopefully with that, I can see all the relative extrema. That's relative minimums and maximums. Okay, so I see the humps. And let's go ahead and find the minimums and maximums. So we'll start off with the minimum. We could trace and approximate, but the calculator has a much better feature. If we go to the Calculate menu, second trace, we'll see one of the options is minimum. We'll go ahead and push enter. Left bound. So we'll move our cursor to the left of the little valley. We push enter. For the right bound, we move to the right. We push enter. The guess doesn't matter much. You can just push enter. And we see at about -1, 28.1. No, I'm sorry. -28. I don't know what that is. Interesting. So it looks like about -1, -28. Do I see that there? Relative minimum at -1, 28. Let me show you the responses. Of course, you should have this out yourself. Relative minimum, -1, 28. So if this was multiple guess, you'd probably figure the answer was D. Let's show you how to do it with the calculator. Now when we go to our calculate menu, we're going to choose maximum. So now we're looking for the left bound of the peak. I push enter. The right bound. I push enter again. And my relative maximum is at about 336. And I see that does indeed match response D. Okay, identify the graph for the function. Remember, this is the greatest integer function. Now, looking at the graph, you should be able to eliminate 2 right away. Which 2 of those graphs aren't functions? Those aren't even functions. So which of these is correct? Well, remember that the greatest integer function returns the greatest integer that is less than or equal to the number inside the symbol. So if I plug 0 in for x, the greatest integer of 0 is 0. 0 minus 2 is -2. When I go here, 0, -2 is not a point. On graph D, it is a point, and so the answer is D. Now, if you graph this in your calculator, you would not be able to tell the difference between B and D, and let me show you how that works. To find the greatest integer, you go math, number, and then number 5. So 1/2 x minus 2, and there's our graph. You'd have a tough time telling the difference between B and D with that graph. Number 16, find the function that represents the graph. So these are piecewise functions. Notice that they each have the same values for the 2 parts of the function. We just have to figure which one's appropriate. So this closed circle means that this is part of the solution set. Now this is the line -x plus 4. So we know that f of x is equal to -x plus 4 when x is greater than or equal to 0. If it's less than 0, we see that it's just simply equal to -2. So it's -2 when x is less than 0. So do we see that graph up there? No, no, Oh, it looks like that's the one. C. Okay, number 17 asks you to graph the function. Not a whole lot of space on your paper, so we'll just sketch a quick little graph. So we'll do the top part first. We know that f of x is equal to 2 when x is less than 3. So we'd have an open circle at 3, 2, and we'd simply have a line going that way. So what is this parabola going to look like? Well, I know that, and you can use your graphing calculator for this, but at x equals 3, this is equal to 0. 3 squared is 9, minus 6 times 3, which is 18, plus 9 is 0. So then I plug 1 in there, I plug 4 in there, I get 1. I plug 5 in there, I get 4, and I get that part of the parabola. Okay, number 18. Identify the graph that represents neither an even nor odd function. So recall, what do graphs of even functions look like? Even functions are symmetric about the y-axis. In other words, I could fold it along the y-axis, and the parts of the graph would match up. No. Oh. So this one, we can see, is symmetric about the y-axis. So this is an even function, so D is not the answer. Now, odd functions are symmetric about the origin, which means if I rotate it 180 degrees, it's going to look the same. So looking at A, if I rotate that 180 degrees, it looks the same. Looking at B, if I rotate it 180 degrees, it also looks the same. So I know A and B are odd functions. So the answer is C. Okay. Number 19, identify the function that is neither odd nor even. Now, the little shortcut is if you have a polynomial, if all the exponents are even, then it's an even function. So this one's even. If all of the exponents are odd, then it's an odd function. Now notice that both B and C have absolute value features in them. So if we use our rule, or our method of finding odd and even, we just plug negative x in for x. So we get negative x to the fourth minus negative x to the fourth here minus 4. So that gives me x to the fourth minus the absolute value of x to the fourth minus 4. So this is an even function. Now here we see a problem because we have an even exponent and an odd exponent. So this one is neither. So the answer is C. Okay, number 20. What kind of transformation is occurring? Well, we know that what's inside the parentheses shifts it in the horizontal direction, but that's the opposite of the number that appears here. So this plus 3 is actually going to shift it 3 units to the left. And then the outside the parentheses number, shifts it vertically. So this is going to go down 5. So it's going to go horizontal shift of 3 units to the left, and then a vertical shift of 5 units downward. So the answer is B. Okay, 21. Now we're given the transformation, and we have to identify the correct equation. So 3 units to the left means there's going to be an x plus 3 in the parentheses. I see that in both A and D. And then 2 units downwards, going to subtract 2 from the function. So I see that the answer is D. Okay, number 22, I want to identify negative f of x. So you have to remember what this does. What negative f of x does is simply reflects it over the x-axis. So which of these is a reflection over the x-axis? Well, you can just kind of sketch on the original graph a reflection, and you can take a look which one of those matches. Well, it definitely looks like B. Well, that is it for part 2. We'll start with problem number 23 for part 3 next time.